Why does a qubit care more about a warm cable than about a curious human watching it? In the energy filament theory, a qubit doesn't die because you look. It loses its quantum edge when its phase information becomes recordable and leaks into the environment. Textbooks loves to frame it as the observer collapses the wave function. But in the lab, the real observer is the room itself, every stray photon, every vibrating lattice mode, every microscopic defect. Every imperfect connector is a tiny witness that can carry away a clue. A quantum state isn't a marble with a hidden label. It's a coherent envelope, like a perfectly timed beat pattern writing on the energy sea. And that beat only stays meaningful if the outside world can't read it. You can picture a qubit like a coin spinning so fast you can't say heads or tails yet. The quantum advantage is that the spin has a phase, a precise rhythm. Now imagine the room is filled with microphones and security cameras. You don't need a person to watch. You just need a device that can store a distinguishable trace. That's where tension background noise TBN matters. It's like the sea surface never being perfectly calm. So your phase gets nudged, blurred, and sometimes tagged in ways you can't take back. Engineers often separate the damage into two clocks. T1 is relaxation, like a battery slowly leaking charge until the energy drains away. T2 is dephasing, like a marching band keeping the same instruments but losing the shared downbeat. So the music turns into mush, even if nobody steals energy. The nasty part is that you can keep almost all the energy and still lose the computation, because quantum computing runs on phase relationships, not just on having energy. The moment the environment can reliably tell this path versus that path, or O-like versus one-like, it starts selecting stable pointer corridors. And your delicate superposition turns into a classic-looking bit long before you feel anything dramatic. So the fight for a working quantum computer is not mystical, it's operational. Lower the noise, weaken the accidental couplings, filter and attenuate every line, trapping stray photons, taming material defects, and stop the outside world from being able to keep receipts about your qubit's private phase. Next, here's the surprising twist. Sometimes the phase looks lost, and then an echo pulls part of its back. Tap follow, share it on New Physics, Clear Universe.